Okay, I'm going to try and explain the radio that I'm going to attempt to build. So I have the idea is to phase. So we're using some phasing networks, but we're trying to do it all digitally. So what I've got is I've got the audio source coming in. This is not really necessary. Well, I mean, I guess it kind of is. Depends on your transmit bandwidth. This is your low pass filter. That's just, all digital. You can do that with FFT. Actually, you can do it in the same step as a Hilbert, which is probably what I'm going to do. But yep, that's just a filter, just audio filter. That's pretty simple. The Hilbert transform takes your audio samples that are coming in, like your microphone samples, and what they do is it will phase shift by 90 degrees. So you will get your regular signal and you'll get your phase shifted signal as well. Um, then you can split that out into two balance modulators. I've got this signal source comes from the AD9854 chip. So you've got an I in phase input and a Q out of phase, well, I mean, imaginary input. I think by default, this one is the Q. The cosine is, no, sorry, no, the cosine is the in phase. The sine is the Q out of imaginary input anyway. So we have two balance modulators. I'm going to do this in hardware because I don't know if I can drive this chip fast enough. Currently, I have the carrier frequency set to 5 kilohertz, and that's just so I can hear it. And you can see it on the waterfall, and we will do some modulation. So I'm going to start it, and hopefully you can hear it without blasting our ears out. And ow, 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 ow. Okay, I'm going to turn that down a little bit. So you can see that there's like some stuff going on now. So that's everything from 5 kilohertz up. That's our transmitted audio. Um, yep, and I've also got a lower sideband. So if I switch to lower sideband, you can I you can almost make it out actually because it's kind of lower, close to the frequency. There you go. But yeah, you get lower sideband and upper sideband. And to listen to both of them, I'll just quickly stop that. To listen to both, all I have to do is move my audio sync from here, which is the output of the mixers, to here, which is the double sideband suppressed carrier, which sounds like this. There we go. And switching won't help here because this is the RF, but I'm actually recording. Well, I mean, not recording. I'm sending the audio of the double sideband modulator to the speakers. I'm going to mute myself just so you can hear all three. So 2 seconds. How do I do that? Oh, yeah. Yeah, I can just do this. All right. So that was double sideband. Now I'll switch it back to the single sideband. We'll execute that. And you can hear the high stuff. So I'll just take my microphone out now. Okay, and I'll go to lower sideband. All right. Okay, there we go. So yeah, that's a bit of a test. Explaining how it works is two balance modulators and some type of mix. Sorry, these are mixers, balance modulators, and then this is a addition. So it's just, I think if you send these two signals to a toroid, I guess that would work. Maybe you can just like use a resistor or something and add them together. So yeah, because yep, they should just add the signals and then you get single sideband because your phase shift on your double sideband suppressed carrier, one of the sidebands is I think 90 degrees one way and one's the other way. And then if you mix that with another one where it's shifted 90 degrees, you get the lower sideband's also 90 degrees and the upper side's another 90 degrees. But because it's 90 degrees again because of the carrier, you get complete cancellation on one of the sides or cancellation on the other side if these balance modulators were perfect, which is probably going to be my trouble. But we will see how it goes. Yep, that's it.